Okay, so in this video, we're going to be talking about number sets, and this is typically a topic that you learn at the beginning of Algebra 1. And it's not really complicated, but it's simply just how we classify numbers. Okay, so don't make it more confusing than it has to be. We're simply just classifying numbers here, and again, this is typically a topic that you learn at the beginning of Algebra 1. Now, in this video, we're not going to be talking about imaginary or complex numbers. These topics typically come up at the beginning of Algebra 2, so we're not going to be talking about imaginary or complex numbers. We're just going to be talking about the numbers that we have listed here, and there are 6 total. We have real, we have whole, we have integer, natural, rational, and irrational. So these are the 6 numbers that we're going to be talking about, and this is essentially how we're going to be categorizing numbers that we come across as we're going through Algebra 1, Algebra 2, and so on. Okay, so let's go ahead and take a look at our first example here. So our first example is the real number. Now, this is really easy to understand because any number that you come across in Algebra 1 typically, okay, assuming you're not going to be talking about imaginary and complex numbers, every number that you come across in this course is going to be real because, again, we're not going to be talking about imaginary or complex numbers. So a real number is any number that appears on the number line. So if you simply just draw a number line, any number that falls on that number line is going to be considered a real number. And it could be a decimal. It doesn't have to be a non-decimal number. So again, I gave you some examples below. You have 1, right? That falls on the number line. 0 falls on the number line. Then you have this fraction here, 10 divided by 5. Well, that's 2, right? So that also falls on the number line. Then you have the square root of 49, which is plus or minus 7. And so again, if you forgot what a square root is, it's simply just a number multiplied by itself. So when I see the square root of 49, I know that 7 times 7 gives me 49. I also know that negative 7 times negative 7 gives me 49. So when we have the square root of 49, we say plus or minus 7. And again, plus or minus 7 falls on the number line. That would be considered a real number. Then we have 5, again, real number, 7.5. Also falls on the number line. It is a decimal, but it doesn't matter. Okay, so that is a real number. Let's go ahead and look at the next example. So our next example here is a whole number, right? So the definition that I gave you, whole numbers are numbers that do not include decimals or negative numbers. So again, they're whole, right? They live up to their name. They're not going to be including decimals or negative numbers. So the examples that I gave you are 0, 1, 5, 20, 50, and 100. So as long as you don't have any decimals, you're good to go. And again, they cannot be negative. Now notice that 0 is included here. Okay, so those are whole numbers. Okay, let's go on to the next example. Here we have the integer. So integers are just like whole numbers. The only difference, they now can include negative numbers, right? If you look at negative 5 and negative 10, right, those are not considered whole numbers, but they are considered integers, okay? But then when you look at 0, 1, 4, these examples right here, you can see that those are also whole numbers, but they're also going to be integers. So an integer can also be a whole number, but the thing with integers, they can include negative numbers, whereas whole numbers cannot, okay? And if you look at the last example that I gave you here, 20 divided by 10, that's going to be 2. That is an integer. Let's go on to the next example. So our next example is the natural number, and this is pretty straightforward. A natural number is just like a whole number. So again, positive numbers that are not decimals, right? But it does not include 0, whereas whole numbers do. That is the only difference, right? So whole numbers and natural numbers are pretty much the same thing. Okay, so examples of natural numbers are 1, 3, 10, 15, 200, 400, and so on. Again, you just cannot include 0. And so what I want to make a note of here, your whole numbers, integers, and natural numbers, those 3 in particular, cannot include any decimals. So if you can remember that, you're in great shape. So again, whole numbers, integers, and natural numbers cannot include decimals. So if you remember that, you'll be in great shape. Okay, we have 2 more to do here and then we're done. Let's look at the next one. It's going to be a rational number. So a rational number is a number that terminates or ends in a pattern. Okay, so for example, you have 1/3. Well, 1/3 is what? Well, we know that 1/3 is going to be 0.3 repeating, right? So this is really just 0.3 repeating, right? Just keeps going on and on, okay? Now, that keeps going on and on, but it ends in a pattern. So that would be considered rational. 15 over 5, what is that? Well, that gives you 3. That terminates. What is that really? That's 3.0. That terminates, that's going to be considered rational, right? Then you have this number here, 7.543, that terminates, it only goes to the thousands place. This right here would be considered rational. -2, same thing, that terminates, that's really negative 2.0, okay? Then you have 5, well that's 5.0, that also terminates, right? So considered rational. And then you have the square root of 25, which we know is plus or minus 5. And again, both of these numbers terminate. They're going to be 5.0 and -5.0. These are considered rational. Okay? So again, rational numbers either terminate or end in a pattern. So if we take a look at the last one, we have irrational. Now make a note here. If a number is rational, it cannot be irrational, and vice versa. If a number is irrational, it cannot be rational. So the definition of an irrational number is just the complete opposite of a rational number. So irrational numbers do not terminate and do not end in a pattern. All right, so I gave you some examples here. You have pi. What is pi? Pi is 3.14 and it just keeps going on and on and on. There is no pattern to it and it never terminates, meaning this is going to be irrational. So pi is irrational. Then you have e, which you probably haven't come across yet. E is Euler's number. It's derived from compound interest, okay? But like pi, it just keeps going on and on and on without a pattern. It's like 2.71 and it just keeps going on and on and on. Euler's number, or e, is also going to be considered irrational, right? And then you have the square root of 2. Now, remember, the square root of 2 is not a perfect square. Okay, there's no number when I multiply it by itself that will give me 2, meaning this is not a perfect square. Okay, so the square root of 2 as a result is going to be irrational. All right, if you plug this into your calculator, you'll see that you'll get a number that goes on and on forever. So whenever you have a square root that is not a perfect square, it's always going to be an irrational number. Same thing with the square root of 7, right? There's no number when I multiply it by itself that will give me 7. As a result, the square root of 7 is an irrational number. So those are the 6 classifications that we can use to describe numbers that we're going to be coming across in Algebra 1. So let's do an example together now. So what I have here is an example that we can do. You can see the key that I have on the left-hand side. I have real, whole, integer, natural, rational, and irrational. And so all we're going to do here is classify these numbers based on what they are. So we're going to go right in order here. So if we do number 1, we have 5. So is 5 a real number? 5 is a real number, right? It falls on the number line. That means it's going to be a real number. So I'm going to put R here. Okay, how about whole? Is it a whole number? Well, yeah, it is a whole number. Remember, whole numbers are simply positive numbers that cannot be decimals, and it does include 0. So it is a whole number. How about integer? Integers are just like whole numbers, right? Except they include negative numbers. So this is also going to be an integer. Okay. How about natural? Remember, natural are like your counting numbers. They're just like whole numbers, but they do not include 0. This is also going to be natural. Now, I just want to stop right here, and what I'm going to do, I'm going to put these 3 in brackets right here. WIN, whole, integer, natural, because if you can remember, right, these cannot be decimals. So if you go ahead and put a bracket around that, maybe that will help you remember that, okay, whole numbers, integers, and natural numbers cannot be decimals, all right? And so just continuing on here, we now have to decide, is it rational or irrational? Remember, it has to be one or the other. So 5 is definitely a rational number. It terminates. It doesn't go on and on forever. So this is going to be rational. Okay. All right, let's go a little bit faster here. -5, yes, that is a real number. How about a whole number? Well, no, it's not a whole number because it's negative. How about an integer? Yes, it is an integer, right? Integers include negative numbers. They're just like whole numbers, but they include negative numbers. How about natural? It is not a natural number because natural numbers have to be positive. Is it rational or irrational? This number is going to be rational, right? It terminates. Okay, so number 2 is done. How about 3, a quarter, which is 0.25? Is 0.25 a real number? Yes, it is real. We talked about that. Pretty much every number that we come across in this course is going to be real. Of course, if you start talking about imaginary and complex numbers, then those aren't considered real, but typically we don't do that until Algebra 2, right? So this is going to be real. Is it a whole number? No. And remember, I have my bracket right here. I know it's not going to be whole, it's not going to be an integer, and it's not going to be natural because it's a decimal. And whole numbers, integers, and natural numbers cannot be decimal. So I'm done there. I know it's not going to be whole, integer, or natural. All I have to determine now, is it rational or irrational? Well, remember, 0.25, that terminates, right? That ends. So it's going to be rational. So RA. As a result, it will not be irrational. Okay, last one, square root of 10. Is that a real number? Yes, it is. It falls on the number line. Whole, integer, or natural, if you go ahead and put that into your calculator, you're going to see that you're going to get a decimal because that is not a perfect square. So it cannot be those 3 right there. Now all we have to determine, is it rational or irrational? Well, it's not a perfect square. As a result, it's going to be irrational. So IR. So that's pretty much it. That is number sets. I hope that you found the video helpful. I hope that you gained something from it. And as always, if you could just go ahead and give this video a thumbs up, that would be much appreciated. And go ahead and subscribe for more math videos in the future, and I'll see you in the next one.